right, so today we are taking what we did in the last lesson and we are now just solving those polynomial equations using factoring. So we're going to learn other ways to solve polynomial equations, some of which really you already know from your quadratics unit. But the steps, if we want to solve using factoring, first thing we have to do is make sure that we've got it in standard form and equal to 0. So get everything to one side, 0 on the other side. Then step 2 is exactly what we reviewed yesterday, to factor the polynomial completely. So go entirely through your order of operations for factoring and make sure everything is factored as far as it can go. Then you'll take each of those factors and set them equal to 0, just like we did in Unit 2. And that will allow us to solve each of those to find each solution. Notice that I put 4 different words here because as we go throughout this unit as well as really the rest of the year, you're going to have problems that say find the solutions, find the zeros, find the roots, find the x-intercepts. These all mean the same thing. So if it says, what are the roots of, and then it gives you an equation, it means what are the solutions? What are the x-intercepts? What are the zeros? Those all mean the same thing. So I just wanted to make sure that we understand that so that when we see different vocabulary, we don't get confused about what we're supposed to do. So example 1a. So step 1, standard form equal to 0. That is already done, so we're good to go there. Now we want to factor that completely. So you should know how to factor this. This is an x squared equation, which makes it even easier. So I go through, there is no GCF, so I look for special products. X squared has a perfect square root. 25 has a perfect square root. And the middle is double those two multiplied together. So this is a PST. So, square root of the front goes in the front, square root of the back goes in the back, sign of the middle is a plus. Now, since it's a squared, that means I essentially have 2 of those x plus 5s. Since they're identical, you don't need to set them both equal to 0 because it's going to give you the same answer. So just set one of them equal to 0. So if x plus 5 equals 0, subtract 5 on both sides, and x equals negative 5. Is your solution, or your root, or your 0, or your x-intercept. All right, go ahead and you try B on your own. Try to go through each of those 4 steps. And then unpause, and hopefully you'll find out that you did it correctly. So step 1, get it in standard form, so I need to move the 15 over by subtracting it. So that gives me 6x squared plus x minus 15 equals 0. Next, I'm going to factor, so I'm going to look, is there a GCF? No, there is not. Could it be a special product? Well, this is a squared, and neither of these have perfect square roots. So no, it's not a special product, which means this is going to be a chart factoring. So this one, because there's a number in front, is split the middle. So that means that in my chart, I'm looking for what multiplies to 6 times negative 15 and adds to 1. So 6 times negative 15 would be negative 90. So I'm looking for something that multiplies to negative 90 and adds to 1. If it's a small sum, that means they need to be pretty close together. So maybe try 10 and negative 9. 10 times negative 9 is negative 90. 10 plus negative 9 is positive 1. So that is our winner. So that means, again, the type of factoring is split the middle. So that means you are splitting this middle term into these 2 terms. So the 6x squared stays the same, but that middle term becomes plus 10x minus 9x. Then don't forget to bring down your 15 and your equals 0. So now, after I split the middle term, I factor it by grouping because it's got 4 terms now. So GCF of this first term is 2x. So that leaves me with 3x plus 5. Whatever this parenthesis is, this one has to be the same. So then I ask myself, what do I multiply 3x by to get negative 9x? And that's negative 3. So first parenthesis is 2x minus 3. The second one is 3x plus 5. Do not forget that you are solving. So just because you factored it doesn't mean you're done. I still have to solve. So set each of these equal to 0. So if 2x minus 3 equals 0, I add 3 and then divide by 2. So x equals 3 halves. Over here, if 3x plus 5 equals 0, I subtract the 5 first, so 3x equals negative 5, and divide by 3. So that means my other solution is x equals negative 5 thirds. And there we go. All right, let's look at the next one. 5x cubed equals negative 625. So first I need to move that to the other side. So 5x cubed plus 625 equals 0. First way of factoring, GCF. They have a common factor of 5. So when I take that out, that gives me x cubed plus 125. So then I look at this binomial. If it's a binomial, that should always kind of send off like a flashing red light that that's a special product. Because binomials, the only ways we know to factor them are GCF and special products, and I already took out the GCF. So I look at my two binomials, difference of squares and sum and difference of cubes. This does have a perfect cube root, so does this one. So this is a sum of cubes. Remember, sum of cubes is the only new way of factoring we've learned. It's the one that uses SOAP. So if I'm using SOAP, don't forget the 5 that's out in front. The signs, it's always a binomial times a trinomial. So the binomial, same sign as the original, so that's a plus. Opposite, so the first sign here should be a minus, and then always positive, so plus. So now we just need to fill it in. The cube root of x cubed is x. The cube root of 125 is 5. Now you base the rest off of this. This term squared is x squared. Middle multiply, so x times 5, 5x. And then last, I'm going to square the last. 5 squared is 25. So now I need to set each factor equal to 0. People always ask about the 5. The 5 is not a factor because it doesn't have an x. So the only parts that need set equal to 0 are these. So here, subtract the 5, x equals negative 5. Over here, that doesn't factor any further, which if I wanted to solve this part by factoring, I couldn't. There's nothing else I can do there. If I were going to solve this, this is a quadratic equation. We spent an entire unit learning how to solve quadratic equations 5 different ways. Just because it's not factorable doesn't mean that you can't solve it. You could complete the square. You could use the quadratic formula. If I used the quadratic formula here, opposite of b plus or minus square root b squared minus 4 times a times c all over 2a. What I notice here is that I'm going to get an I because inside here I end up with 25 minus 100. And if I've got a negative under the square root, that means that these are going to have imaginary solutions. So I always get people confused, and I don't want you to be confused here. It's not that there isn't a solution, it's that the solutions are imaginary. And later on in this section, we will solve for all the solutions. So yes, you still need to remember how to solve a quadratic. Here, The key is that it asked for the real number solutions. And since these are imaginary, they're not real numbers, which means the only real answer that we have is x equals -5. All right, moving on. D. So first thing, because it's already in standard form, is to do the GCF. So GCF there is 2y. Leaves me with y to the 4th minus 9. So now I look to see if this factors further. This does. Y to the 4th minus 9, those both have perfect square roots, which means that this right here is a difference of squares. So I still need that 2y out in front, but that y 4th minus 9 is going to factor further. So as a difference of squares, the square root of y to the 4th is y squared, so that's what goes in the fronts. One's always a plus and one's a minus. Square root of 9 is 3. So I end up with these as my final factored answer. Again, set each factor equal to 0. This one is a factor because it has a variable. So now solve each of them. Here I just divide by 2 and y is 0. Here I would subtract 3 and then take the square root. But again, here I'm taking the square root of a negative. So note that those are imaginary, so I don't need to list those, at least not in this section. And then over here, y squared equals positive 3, solved by taking square roots, y equals plus or minus radical 3. So that's two solutions right here, positive radical 3 and negative radical 3. And here's a third solution, y equals 0. The other solutions are imaginary, plus and minus I radical 3. All right, last one. All right, I've got some moving of things to do. It needs to be in standard form, so x to the 4th plus 3x cubed. When I move this over to the other side, it's going to become negative, so negative 16x squared, and then minus 48x equals 0. So first thing here, I've got a GCF. All four of these terms have an x in common, so I'm going to take that out. And then what I have remaining here is 4 terms. The only way that we can factor something with 4 terms that we know is by grouping. So I'm going to factor the rest by grouping. Do not forget that that x is still out in front there. So the rest of it, the GCF of this first group is x squared. So that gives me x plus 3. If this is x plus 3, then this has to be x plus 3. What do I multiply x by to get negative 16x? I multiply by negative 16. So now, again, not forgetting this x that was out in front, the grouping part of the factoring, this gives me x squared minus 16 from what was out here, and then the shared parenthesis is x plus 3. I am actually not done factoring this yet. Hopefully you look at this, and when I say that, hopefully you look and you see exactly what needs done. This right here is not in simplest factored form. That factors further because it's a difference of squares. So if this is a difference of squares, that means it is going to go down into 2 more parentheses. Square root of x squared is x. One gets a plus, one gets a minus. Square root of 16 is 4. So this turned into this. Then I need to bring the x and my x plus 3 down. It is all equal to 0, so that means I need to solve each of these. So this has a variable, so it gets set equal to 0. So does this, x plus 4 equals 0. Here, x minus 4 equals 0. And here, x plus 3 equals 0. So now, this one's already solved. This one I subtract the 4, so x equals negative 4. Here I add the 4, x equals positive 4. And here I subtract 3. So I've got x equals 0, x equals -4 and +4, and x equals -3. So I have 4 separate x-intercepts here in this particular function. All right, so hopefully after 2 more days of reviewing factoring, you feel comfortable with it. If not, please see me to get some extra help because you've got to be able to factor. That is it for this lesson.